Hi guys, welcome to another episode of Math Made Easier with Delmi. Today we'll be looking at integral of infinite term, and here is our infinite term, and the infinite term is a cube root of x. So that means that for the first term we'll have cube roots of x, which can be written as x exponent 1 on 3. So that means the second term will be a cube root, okay, a cube root of the a cube root of another cube root, okay, of another cube root of x, which will be equals to x exponent 1 on 9, okay, which will be 1 on 3 times 1 on 3, which is 1 on 9. Then the next one too also would be, the third term will also be the cube root, okay, the cube root of another cube root of another cube root, okay. This is the first term here. The second term is this, okay, and this second term is having this cube root, and this cube root, okay, on it. So for the third time, it's having this cube root, and this cube root. So 3 different cube roots on it. So that means that it will be the cube root of x exponent 1 on 9, okay, is the simpler form. So that will be x exponent 1 on 27, and it continues like that. So that means that the terms of the infinite term will be it means that the terms, when we break them down, will be x exponent 1 on 3, okay, x exponent times x exponent is a times, okay, times x exponent 1 on 9 times x exponent 1 on 27, okay, times x exponent 1 on x exponent 1 on 27 times 3. That will give us 81, okay, the x exponent 1 on 81, okay, and continues like that. That we realize that the x's don't change, okay. What changes is the exponent. So what we do is, when we multiply the whole term, okay, we realize that what we do is, because they have the same base, okay, the law of indices, we apply the law of indices. So with the same base, then all the powers will be added, okay. But remember, our term is an infinite term, so that means that we'll be adding them to an nth term. We'll be adding to an nth term, which is up to infinity, which we don't know. Is that clear? So if it's an nth term up to infinity, and the powers are following a geometric progression, the powers are following a GP, that means that multiplying all the terms, okay, we'll get to an expression, we'll get to a term which will be x exponent n, and the n is in geometric progression. So that means the n will be the sum of infinite, the sum of infinite term of a geometric progression, which will be the sum of this, because the sum of infinite term, which will be equals to a on 1 minus r, okay. But remember, our first term, our a is x, our a, the n stands for the exponent, so our a will represent the exponent, the first exponent. So our a for the first exponent, okay, our a will be the first exponent, and the first exponent is 1 on 3, so our a will be 1 on 3. n r, which is the common ratio, okay, and the common ratio is 1 on 3. the first ratio on the second term on the first term. Okay, so you get 1 on 3. So we use this and you use that to solve the solution. So let's say, remember that we had said that A, remember we say that A equals 1 on 3 and R equals 1 on 3. Okay, so we substitute this into this. Okay, so we have this implies that n will be equals to 1 on 3 all on 1 minus 1 on 3. And that will be equals to 1 on 3 on 2 on 3. Okay, and that will give us 1 on 2. So that's n equals 1 on 2. Alright, so this means that we have the integral of the cube root of 16, 1, okay, the integral from 1 to the cube root of 16, x exponent n, which is now 1 on 2, okay, dx, so equals 2. We must get 2, okay, we must get 2. So this is just a constant. This 2 is just a constant. All right, so we can now integrate. We can now integrate our what we have here. Okay, so integrating that we have x exponent 3 on 2 on 3 on 2. Okay, so the value from 1 to cube root of 16, 1 to the cube root of 16. Okay, everything should be equals to 2. So we have, this implies that, so dividing this, so simplifying this term, we have 2 on 3. Okay, so we have 2 on 3. So 2 on 3 x, okay, x exponent 3 on 2. Okay, still from 1 to the cube root of 16, and we must get 2. All right, so let's substitute the value now. So we have, this implies that 2 on 3, okay, so when x equals the cube root of 16, okay, when x equals cube root of 16, so cube root of 16 can be written as 16 exponent 1 on 3, right? Exponent 1 on 3 times 1 times 2 on 3, okay, times 2 on 3. Oh, sorry, it's 3 on 2 times 2, 3 on 2, sorry, 3 on 2. Let's check. Yeah, 3 on 2. Okay, so 3 on 2. Then minus 2 on 3. Okay, then in bracket when x equals to 1. So we have 1, then 3 exponent 3 on 2. Okay, all should be equals to 2. So we have, this implies that this here, the 3 and this 3 cancel out, so we have 2 on 3. So you have 16 exponent half, that will give us 4. 16 exponent half is 4, so we have 4 minus 2 exponent 3, okay, times 1 one exponent any number, one exponent anything is 1. Okay, so 1 equals, we still must get 2. So we have here, this implies that 8 on 3 minus 2 on 3. We still must get 2. So we have, this will give us 6 on 3 equals 2. We still must get 2. So 6 on 3 is 2. So we have 2 equals 2. So that means we have proven that the infinite term, the integral of the infinite term that we have above is equals to 2. And that is that. Proven. Thank you for your attention. Make sure you like, subscribe, and don't forget to share. Do not forget to like, subscribe, and turn on the notification button.